Hand over to Ali to talk about Koolzone and supply chains. Thank you.
Thank you. Well, I can't really see everybody because it's a little bit bright. But this is, I think, this is the third time I've spoken at a TTN conference, twice in the UK and once in Amsterdam. So delighted to be back. And I wanted to refer to a couple of things that throughout the talk that Wenke said at the beginning, because it was so pertinent, having gone through the journey of a startup company over the last 5 years. Everything he said kind of resonated. So he started off, one of the things he said was, it's not about the idea, it's about the execution. And he talked about, for those of you who may not have been here, he talked about blockbusters who had an established market, and then Netflix come along with better execution, adopting new technologies, and they kind of take over. So when we started off in temperature monitoring of fridges and freezers. It wasn't new, people did it, but they just didn't do it as well as we wanted to do it and the way we knew we could do it. We had experience in real-time monitoring. My son, at the age of 2, developed type 1 diabetes, and so although we didn't actually develop a constant glucose monitoring solution, I worked with companies to adopt better technology and bring it into the UK. The original products were big, hard to use, expensive. Trying to stick a box almost the size of half the size of a shoebox on your son's 2-year-old bottom really was not very comfortable for him. And so I had a lot of experience in real-time monitoring, but we also wanted to monitor the temperature of fridges, of the insulin in the fridges, because we were losing it at times when the fridges broke and things, doors were left open and so on. So we set about building our own product. Pretty stupid, really, because as Wenke said, building hardware is hard. And we set about building the sensor, the gateway, and all of the back-end software and application. The only thing I think that wasn't ours was the plug that plugged the gateway in. So we set about with our premise of trying to make something really easy to use. Plug and play is a really overused expression, but something that was easy and could scale and so on. So our product got us into the market. People don't come and ask you for your product. You have to go and get it out there. So initially, we had an office we started up in Germany and over here, and we went out and walked around the streets asking local restaurants, local cafes, local bars, if they wanted to try the technology. And that was a really important thing because it got us out there. We gave it them for free in the early days, but it got us communicating with customers, finding out what they liked and what they didn't like. Throughout that, we eventually started to scale up a little bit, winning slightly larger customers, and then the turning point was we got involved in a 10-month evaluation at a global airline catering division that had 300 and something locations around the world, and they did a 10-month evaluation of temperature monitoring. We were a very early company at that stage, and we were competing against the likes of Rotronics, who were a 1965 founded Swiss company that just specialized in that market and had a banner of quality and so on. And we were also up against some other sort of blockbuster type companies. And at the end of the 10-month evaluation, they chose Koolzone, which was great. However, our product was a Wi-Fi based solution. The gateway used Wi-Fi. It was only ever going to be as good as the customer's Wi-Fi. And that might be great at certain times of the day, and other times we might lose the signal. And the sensor worked out the fridge, worked out the freezer, no wires, but really, the range wasn't good enough. So to try to do an organization like a huge airport site, it was never going to work. And along came LoRa. Wenke said about fairy tales. We thought it was a fairy tale. We thought that this would be great. Traditional type of topology, sensors, gateways. At the time, it was all very early days. We worked with Multitech, who were an established gateway company, but had a fairly new LoRa module within their gateway. And then, of course, TTN. And then we had our own back-end system we continued to develop. So we continued with our back-end, but we started to partner with companies and try to jump on this early stage LoRa bandwagon, and we thought that we would sail into the distance. However, it was not easy. It really wasn't easy. The whole standards around LoRa were not very well defined, were open to interpretation. It was all so new that really getting things to plug and play was not a reality. You could get things working, but you couldn't necessarily get them to stay working. And you couldn't necessarily get them to work in the environment that you wanted. So we did lots of tests with hundreds of sensors trying to connect to multiple gateways and simulating real-life situations where maybe power would go and then all the sensors would try and come back on again. And we'd end up with many, many sensors not joining, some kind of perfect network storm, everything up on spread factor 12 that had joined, and it was a bit of a nightmare. Anyway, we worked with our suppliers. TTN were great. We eventually moved across to a TTI, our own private instance of the Things network. And everyone worked with us to help us. So when we started to get involved in going into other countries, we found a whole new set of problems once we started to try and do 915 or 923. Over the years, we've now, and I say years, that sounds like we've been around a long time. It is only less than 5 years. But we've moved from being in just temperature monitoring of fridge and freezer temperatures into a much wider range. Another thing Venka said is that, don't build prototypes for free. There are an awful lot of people out there that want you to use your expertise to build them something or want to help them with something, and they want it for free. And it's inevitable. You see a big opportunity. You think, oh, yes, if I could just build a prototype, that will give me this business. And it's not necessarily like that. People will use you and then dump you. So you have to be very careful what you do. And we got sucked in the early days of thinking about building a prototype. One of our first prototypes that moved us away from our market was actually a CO2 for high percentage CO2 in incubators. Fortunately, we've sold it a lot of times since then, but it could have been a different story. So we've got into a wide range of markets since those early days. Food, retail, hospitality, manufacturing, catering. So that's kind of still our core kind of area. But we've moved up into very large scale now. And we've also moved into sort of helping manufacturers, food manufacturers, get the best out of their system. So if you have some kind of cooking equipment, using internet enabling it using our products, they can get a better view of how to fix that product first time when they go out. So the whole area around servicing products. But it also gives the customer a better view of whether the food is being cooked safely and whether the product, which can sometimes be a dangerous product with very hot temperatures, is being used in the right way. In addition, we've had to move into other areas such as humidity, door opening, all these things that people want. You get in with one thing and then that is a wedge that opens up a whole load of other demands. We've moved big time into the laboratory, pharmaceutical and life sciences market. We have a global customer, I think I said this at one of the last talks I did, who contacted us from New York, and they wanted to replace an existing system because it didn't really work, and they had heard of us. Don't know how they heard of us, but they had. And they asked us to ship a liquid nitrogen product, a -80 product, and a normal fridge and freezer product and send it over to New York, which we did. They installed it without any help. They started using our platform without any help, and they rang us up and said, we want to now place an order for several hundred of these. So they've rolled us out now across various states in America, over in Europe, and so on. And we are now their standard product of choice. In addition, we've got into energy monitoring. People want to know, of course, how much these products consume, and I'll come on to that a little bit later. Another area we've been pulled into is it's fine monitoring fridge freezers, static fridge freezers, but then people want to monitor on the move. So we've had success in working with vehicle manufacturers who want to build our product into their vans that are at events. We can monitor the temperature of the fridges. We can work out whether there's a power failure or whether there's anything that's going to damage the fridge freezers. And we can also geolocate it, of course, if there's any problems and they need to send an engineer out. Other areas. We're a fridge monitoring company, but again, people don't want to necessarily buy a technology, an IoT technology, and then find they have to buy another IoT technology, a whole stack, and another one, and another one. So within reason, we've started to expand into other areas. Sometimes we make the sensors, and sometimes we don't make the sensors. So as we all know, there's a lot of LoRaWAN sensors out there. Some of them are good. Some of them aren't so good. They all have to be tested, and they don't all work the way you expect. So one word of caution, if anyone's trying to do this, you might get a sensor, and you might you might integrate it into your system, and you think, oh, that's working well, and then this happened to us relatively recently. You then order a batch of them, and you find that actually, because it was so early stage, there's so many changes being made to it that you've almost got to start again. Energy. Just a couple of basic facts, as I think it's difficult to know the exact quantities, but there's something like about 3.6 billion units of, items, pieces of cooling equipment out there, whether it be air conditioning or refrigeration. It uses an enormous amount of energy, and with global warming and increasing population and urbanization, the estimate at 2050 is like huge. I think it's getting on for 4 times the size. So the energy sinking into cooling things is a big problem, and we want a big European grant for some of the work we're doing around monitoring, because monitoring and keeping the temperature at the right temperature not only keeps the food safe, but stops people overcooling, which has a big impact. But also looking at we're working on lots of further algorithms to work out how to predict things from temperature without having to put expensive energy monitoring systems in. So at a global level, it's a huge problem in terms of cost and carbon footprint. And at a more micro level, there's a few facts there at the bottom about, there's some of the things that if you're running a restaurant or you're running a hotel or whatever you might be doing, or even domestically, the costs of refrigeration, if you leave a door open, if you have a poor seal, if something from a maintenance point of view is going wrong, you can count the number of pounds or euros or dollars sort of disappearing out your pocket. So one of the things that we're doing is improving our system to be able to allow instantaneous looks at how things are working of a product, the relative performance of a product. So one of the companies we're working with uses our systems, our sensors and our temperature sensors and our energy monitor, our whole stack, to look at relative performance of laboratory equipment. So there's products like Liebherr, there's products like LEC, there's products like BioCold. They're all different types of biomedical refrigeration units that go down to extremely low temperatures. And they have a difference in cost. And procurement in these organizations within universities and NHS and stuff, they'll say, oh, well, you can buy this one that has the same spec, but, and it's hugely cheaper. But with the work that we're doing with this organization, you can see that actually it's a false economy. You might save even like £1,000 or £2,000 on the initial purchase, but you might be burning on the same capacity unit in its standard state with the doors closed. You can be burning sort of £900 a year more electricity in the cheaper units. And not only that, we store all kinds of things, like we are storing a lot of products relating to cancer. We store brains at a hospital in Oxford. We store small animals. We store anything. Around the world, our customers in the biomedical world are storing all kinds of anything to do with the human body, the animal bodies, any fluids. That's what they store for long-term storage and also for shorter-term storage for research. So it's really important that these products that you're trying to keep a long time are kept at the right temperature. And one of the things that you can discover by using this technology, that if you take these 3 different freezers and you open one door for 1 minute and you shut it, the good one will probably cool back down to temperature, well, no, not probably, will cool back down to temperature within the minute. On the other hand, the cheaper one, you open a door for 1 minute, it could take you 4 hours to get down to temperature. So if you're opening that door several times, which they would want to do in a laboratory, you are actually keeping your product at the wrong temperature continuously. So we stopped building hardware, and then we thought, aha, we'll try again. We thought it was a good idea to build again because actually we'd looked at all the sensors out there and there were still limitations. Battery technology doesn't like cold. Crystals drift at lower temperatures. And even just the casing designs, these things would break when you pull them out of a cold freezer. So we've developed a sensor that can be dropped at -40. We've developed a sensor with an internal aerial so that it doesn't detune if the aerial suddenly touches something within the fridge. We've developed a product that does have a long, long battery life. I don't know how many people have quoted, you know, oh yes, this sensor is going to last for years of battery life. And then when they actually start doing a trial, they find that the reality is very much different. So we have developed a sensor, I've got one in my back pocket, a sensor that we tried to make it look, it actually looks a little bit like a robot, which was not initially the intention, but we quite like the look. It's meant to be sort of more of a non-prototypey looking product, non-technical looking product, and something that people, a very forgiving product. So you can literally put it in water, put it in hot water to wash it. You can chuck it in your fridge. There's various fixing products that we've got that you can attach to any device that you want. So we've built what we believe using grant money and our own investment and our customer revenue income, a product which we think is the best temperature product in the market. But not only that, we've built it with expandability in mind. So this happens to be just a temperature one, but it has all the I/O to connect all kinds of analog, digital I/O to the product. So, how am I doing for time? Oh, I've got 10 minutes. Okay, fine. So, the other thing is getting these things to market. You can build a great product. We've driven the price down substantially as well. Our aim was to half the price of other sensors on the market, the cheaper sensors on the market. And that's what we've managed to achieve. But as well as that, it's about provisioning these products. We've provisioned thousands and thousands of sensors. And when you put them out, when you're trying to get them out there, configure them, get them out there, the cost can be enormous. When Venka said, keep your margins high because customers don't want you to go out of business. But actually, they'll try and drive the price down. That's what they do. They don't think about that. They may not like it when you go out of business, but at the time, they'll try and eke every penny they can out of you. So it's really important that not only you have low-cost product, but that you can get it out there without a huge amount of labor. And also, when it's out there, you can't afford to have any problems. You can't afford to have issues in the field, because any one sensor going down in the field could wipe out a huge proportion of your margin, particularly if they're in far-reaching places. We've got customers in Malawi, we've got customers in Hong Kong. I was over in Hong Kong doing an installation, big installation, when the protests had, back in July, when the protests were just heating up. And incidentally, there was an awful lot of food lost at that particular place when I was there, something that we actually couldn't stop, but they lost over 10,000 airport meals in one afternoon because we all got evacuated because of the protests, and everything just had to be left and then chucked away the next day. So unfortunately, Koolzone couldn't save that. It's important to keep everything streamlined, as I said. So we've worked hard on provisioning tools, provisioning rigs that allow us to configure sensors just by sliding the box underneath without even opening the box, which has got a number of sensors in, slide it under, and then it's configured for the customer, ready to go. We have worked on tools. Some of them are other customers' tools, like, for example, Multitech have a device HQ for their product, and we integrate those kinds of products to be able to help us to have a really, really, really good support system, network operating, network control system for our big network. The other thing I wanted to show you was making it accessible for everybody. So we then will ship out large numbers of gateways, big, huge boxes of sensors and stuff. But we wanted to make this accessible to everybody, and sometimes buying at that level doesn't work for people. So whether you're a big corporation or whether you're a small company, having something that you can make an impulse purchase on will often help. So we've created something called Take IoT Away, or Take It Away. And in there, if I put my other sensor back in, I don't know where I put the other sensor. Oh, I've already put it back in. So in there is actually a TTN gateway and 4 sensors. So for this, it comes bundled, ready to go, open it up, plug it in, a little instruction sheet on how to just connect from your phone using your phone to the Wi-Fi. Put your sensors in your fridge or freezer. As I said, you can go down to -40 with that product. And log in with the login you're given, and you've got a fully functional IoT system that gives you graphing, reporting, alarming, accessible from anywhere on your phone, on your PC, and so on. So it allows people to start small and scale. So that might have a TTN gateway in, but equally well, we do one with a multi-tech gateway in, and you can just scale these. They start small, but you can scale to any size you like. So that's the product. And this is just an example of some of the screens that we do. We wanted it to be really intuitive. So if you're selling potatoes, you might want to have a screen that has got potatoes in the back, and you might want to pick your sensors there, or some of your sensors that are relevant to you, and have them displayed on a large screen, or on your phone, or whatever, with something that looks familiar to you. Of course, we've got maps, we've got control panels, we've got plan views. You can upload anything you like. So we've worked hard to give our customers a lot of visualizations that mean something to them. So, our strengths. Talked about the temperature sensor that we've developed, and we will be extending that. We've already extended it to have PT1000, which is will take us down to the -200 and the -80 with that sensor. We've already made humidity sensors. We just haven't made a large batch of them yet. So that will continue. We have a large sensor portfolio. We don't make them all. We've just made a particulate sensor for people, for an organization, a construction company, and we made that particulate sensor. In fact, the chap that's made the particulate sensor for us, one of our employees, is here in the room, I think, although I can't see anything. And I think he took about using our expertise and everything we'd done before, we turned that around in about to a working prototype that could go into the customer within about 2 weeks. We'll do bespoke sensor development, but we won't do it for free. We've fallen into that trap, just like Venka said, and it all looks really good. It's like the company that says, I only need about 1/8% of this company's business, and then I'd be really successful. But people have fallen into that trap before and gone out of business as a result. We're good at adapting to other frequencies. You can get these sensors and you can just, NFC them or whatever to make them 915, 923, and they should work. But I'm telling you that they don't. In all instances, you have to work hard. We're good at optimizing LoRa. We're good at calibration. Temperature, in a lot of instances, requires calibration. It's a dark art. A lot of people don't understand it. We understand calibration. We understand all the levels of calibration you can do right up to UCAS, ILAC standards. We have a resilient end-to-end solution. Our platform is easy to use. You don't need a manual. We allow our customers to do as much configuration of the platform as they would like. And we're good at complex installations. Just harping back onto the Hong Kong installation, LoRa's really good distance. We all know that. But I was in this Hong Kong airport, and I couldn't understand in one part of the building, I could not get a single signal out of these fridges and freezers. Now, they were big. One freezer was this size, and they have big hydraulic doors that close. And I couldn't get a signal however close I got with the gateway. So I then got the sensor out and I put it right next to the gateway. And even then, the signal-to-noise ratio and the signal strength was appalling because there was so much interference in the buildings. In that edge of the building, there was so much radio interference that it just deafened the gateway. So we have a lot of good tools to work out what's going on. So we identified what the problem was, and then we were able to fix it. So that's me done.